Hi, today I'll be covering some topics on concurrency mechanisms for operating systems. These topics are Futexes and two-phase locking. Just to briefly go over concurrency. So concurrency allows computers and processors to coordinate execution of multiple threads or tasks and ensures safe access to shared resources. The reasons why concurrency is needed is to prevent some pitfalls like race conditions. It also maintains data consistency and manages concurrent access effectively, allowing multiple threads and processes to access the same resource without conflict. Other areas where concurrency helps is also in solving synchronization problems, which include deadlocking or starvation. Some of the more common mechanisms that we've explored throughout our class are mutexes, semaphores, and condition variables. And then today I'll just be going over the futexes and two-phase locking. So Futex stands for Fast User Space Mutex. As the name suggests, it is simply another mutex, except a more specialized form designed specifically for Linux systems. The idea behind Futex is that it reduces the need to involve the kernel in order to make specific to make acquiring a lock easier. So for the common case where no other process is holding a lock, uh, the process attempting to acquire the lock doesn't need to go into kernel mode or make a system call in order to acquire it. It can acquire the lock all within the user space. Any threads attempting to acquire the lock also need to do it atomically. And as you can imagine, since acquiring a lock can be done in a user space if it's free, it improves the performance of programs using a Futex. Here is an example I was able to pull from GitHub, mainly to show how Futexes um, wait to acquire a lock. This piece of code here is a wrapper function that the developer had designed um, to put a Futex into a waiting queue and waiting for a specific value to be presented. And then they also created a wrapper function for waking up other Futexes that are acquiring a lock after it's been released. So for this specific example, uh, the developer had forked a process that immediately goes into this waiting queue and waits for a character A to be sent. And then in the parent process, the parent wakes up its child by sending the A using this function, and then puts itself immediately into the waiting queue as well, waiting for the character value B. when the child wakes up, it it broadcasts the value B in order to wake up the parent. And at that point, the program essentially is able to finish. So, just to explain some of the contention or handling contention with futexes, if a lock is already held, a thread uses a system call to wait in the kernel. The kernel will put the thread to sleep in the queue associated with that futex. When a lock is released, releasing thread will make another system call that wakes up any futex or wakes up any threads in the waiting queue. As you can see, this process will slow down the system or slow the program down if there are multiple threads trying to fight for acquiring a lock. And as you can imagine, the reason also for Futex to operate in a user space when the lock is free is a happy path. And when Futex are more widely used is when the program or the developer believes that there should be less contention around acquiring a lock. So as I've mentioned before, the advantages of using the Futex is a higher performance in the cases when there's less contention for acquiring a lock because there is less context switching, making it less overhead to acquire the lock. Creates efficient use of the resource, and then is also very highly flexible. Some of the disadvantages, without careful programming, the developers could face potential issues, much like deadlocking, if it is not performed correctly. There's also the issue that futexes are very platform specific and can only be used within Linux systems. So when developing an application that uses futex, the developers will need to be mindful whether that application would be used in a Windows environment. Next, I also just briefly wanted to go over two-phase locking. So this is another concurrency control mechanism that is more widely used within database management systems. Two-phase locking ensures serializability. So that just means that when a thread or process attempts to change a shared resource, or when multiple processes are changing a shared resource, those changes are made in some sort of order. In two-phase locking, the two phases are the growing phase and shrinking phase. These phases only refer to acquiring the locks during the growing phase and releasing the locks during the shrinking phase. One crucial rule on two-phase locking is that all locks must be acquired before any of the locks can be released. Here is a simple diagram just showing two-phase locking. So during the growing phase, um, to begin, the process will go through the growing phase of acquiring both locks, and then a during the lock point when both locks are acquired, that is when the process will make any operations to the shared resource. And afterwards, once it's done making its changes, it will release both locks during the shrinking phase and complete its processes. Here's some of the advantages and disadvantages for using a two-phase lock. Again, it guarantees serializability, ensuring that any changes made to a shared resource are done uh, in a specific order. And it's also just easy to implement since it is just acquiring two locks. Some of the disadvantages with using a two-phase lock system is it reduces concurrency because of uh, the need to acquire both locks, and also could possibly cause starvation. Uh, One of the reasons also why I decided to present two-phase locking with Futexes, as you can understand, two-phase locking can cause a high amount of overhead since there are two locks, and the need to wait for those locks can cause slower performance within programs. But in the cases where changes can be made without um, if in the cases where changes can be made with the locks not held already, uh, using a Futex can improve the performance of those two-phase locking system. And so that's why sometimes Futex goes hand in hand with these two-phase locking mechanisms. So again, Futex is just another mutex designed specifically for Linux systems and optimized for the cases when locks aren't held by other processes. And then two-phase locking is a, a mechanism widely used within databases that ensures uh, order or serializability when uh, when making changes to a shared resource. Hopefully, you all learned something here today. I'm glad to make this presentation, and thank you for sticking around.